Machine learning is a field of computer science that gives computers the ability to learn without being explicitly programmed. What is deep learning? Deep learning is a subfield of machine learning that structures algorithms in layers to create an artificial neural network that can learn and make intelligent decisions on its own. Examples of machine learning and deep learning are everywhere. It's how Netflix knows which show you'll want to watch next, how Facebook knows whose face is in a photo, what makes self-driving cars a reality. The difference between deep learning and machine learning is, in practical terms, deep learning is just a subset of machine learning. While basic machine learning models do become progressively better at whatever their function is, they still need some guidance. If an AI algorithm returns an inaccurate prediction, then an engineer has to step in and make adjustments. With a deep learning model, an algorithm can determine on its own if a prediction is accurate or not, through its own neural network. Tensorflow is a framework by Google for creating deep learning models. Tensorflow took the world by storm because it is free, relatively easy to use, and gives developers with entry-level machine learning backgrounds access a powerful library instead of building all their AI models from scratch. TensorFlow was created with processing power limitations in mind, making it easier for mobile and web developers to make use of the library and create AI-powered features for consumer products. Now let's see the 3 most common applications for TensorFlow. 1. Image recognition and processing. 2. Human language-related features. 3. Models for data analysis. In this video, we are going to see how to run an image classification model called Posenet on the browser side, and to import its results in JSON format inside Unity. There are 2 ways to achieve this. One way is using Barracuda package in Unity. Barracuda is a lightweight cross-platform neural network inference library for Unity. The Barracuda neural network import pipeline is built on the onnx, Open Neural Network Exchange, format, which lets you bring in neural network models from a variety of external frameworks, including PyTorch, TensorFlow, and Keras. But, if we use this approach, we have to convert our TensorFlow models to onnx format first. And currently onnx conversion tools doesn't convert all models to onnx. Only few model architectures could be converted to onnx format. In future this will change. Since we are only interested in a Webgl build, there are other ways of achieving this, like, we can run the TensorFlow models from browser side and send the model's results to Unity in JSON format. When building content for the web, you might need to communicate with other elements on your web page. Or you might want to implement functionality using web APIs which Unity does not currently expose by default. In both cases, you need to directly interface with the browser's JavaScript engine. Unity WebGL provides different methods to do this. I will provide the different methods link in description. Simple way to do this is by using Unity instance.sendMessage function. But first, we have to run our Posenet deep learning model from browser side. You can do this by simply following the coding train tutorial. I will give the tutorial link in description. Once we get our values from Posenet as a JavaScript object, we have to convert it into JSON format using json.stringify command and send them to Unity side using Sendmessage function. And from Unity side, the sent JSON values can be parsed using JSON utility. But there is a catch. Unity does not support passing other types directly to the API, such as primitive types or arrays. So, we have to manually construct JSON into simple format, if the JSON values are given by TensorFlow models in an array format. I used the following code to convert JSON array to simple JSON format. Once the values are inside Unity, we need to plot the values in Unity Canvas. Since Posenet model input resolution is 640 x 480, the canvas also should be in the same resolution, else point will mismatch. For this issue, use aspect ratio fitter to fit the canvas in fixed resolution even if the game is in full screen mode. If you face some resolution issue in changing screen point to world point, first convert the JSON values to viewport point values for normalization. Then convert the normalized values to world point.